Today on Random Stuff we're going to take apart. Hi guys. Right, we have a mains inverter here, and I thought I'd have a look inside one of these because a lot of the people of my age, and I'll leave you to guess what that is, will remember when these started turning up, and they were big things based on big clunky transformers. They were almost always pure sine. 2 transistors, a feedback winding, and a mains transformer was generally all they used, and then your output transformer fed the outside world. With the pure sine stuff, a lot of it is still done that way. Certainly with UPSs, I think most of them go that way as well, with some clever trickery to try and do a bit more management. But a lot of them have gone the modified sine route, which is what I believe this one is. And modified sine allows you to pack an awful lot more power in with a lot less size, because we're not using that huge transformer. So let's crack this open and we'll have a look inside. I'm pretty sure this is a modified sine. This is exactly what I'm talking about. This is also new old stock. I don't know how old this is. There's no date on it. But it was boxed brand new in a big pile of stuff we got. So I will crack this open. These can be quite a pain to get apart, so there may be an element of struggling with this one. Mostly because we heatsink all our transistors to the case, and this is a single piece case. Actually no, it's not. That's good. But quite often they are a single piece case, which can mean that you're having to reach in with long nose pliers and undo nuts, and then you've got to try and get the nuts back on, and yeah. Modified sine is okay for some stuff. It's definitely not okay for other stuff. Capacitive droppers do not like pure sine, modified sine. We used a couple of these to power stuff up on some new kit we built, and promptly blew the capacitive droppers out of the kit. So we've got our screws out. I believe that should slide out somehow now. Well, it's only going to go one way, is it? No. Right, okay. There we go. What have we got here? We have an earth, so it's got to go out that way. And there we go. Right. First thing, any of you that have not looked into one of these before, but do know your electronics are going to be saying, is that's a switch mode. And broadly speaking, yes, you're correct. Anything like this is a switch mode. But this shares a lot more in common with a standard main switch mode power supply than the other inverters do. So a typical circuit for an older style transformer inverter, I'll pop up there, and generally it's 2 transistors with a feedback winding or an arrangement made for feedback driving a big mains transformer. A lot of the early ones use big toroids or massive open frame transformers, and you're talking about a unit twice the size of this, sort of probably out to there and out to there, to provide you 100 watts. And this is 150 watts, and this is a larger one, to be honest. I've seen smaller, but again, this isn't a cheapo cheerful Chinese one. This was a decent brand. So what we've got in here now is more akin to a mains power supply. So we've got our 12 volts coming in. We have a power supply controller chip down here. Might not even be something as spectacular as a power supply controller chip. That is an NE556 there. So that's a cousin of our venerable 555. I think that's probably a dual. We have a 4013 there, so that's CMOS logic. And I can't quite read that. That could be a power supply controller. Sorry. So that could be a power supply controller. I can't see much on it. I think it is a standard LM39 something, so nothing special. So what's happening is we are producing a high frequency switching control signal, much the same as a standard switch mode would do. We're then blasting that off through our switching transformer here, And we have more chippery down there. KA3525A, don't know what that is. And can't quite see what that one is. So we're feeding that through. We're then rectifying it out through these diodes here, which give us a nice high voltage DC. And then rather than say with the older system, the output of the transformer was where you went. What we're doing now is we rectify it out to DC, and then we have a row of MOSFETs most likely here, which are then used to produce a modified sine. So there are generally 3 steps in modified sine for each half. Is that right? 3 steps. 0, a half volt step, and then a full volt step, and then obviously we repeat that in the other direction. So that's what these are doing, and I would imagine potentially these would be involved in generating that. We'll grab those chip numbers, and as I talk through them on the video, I'll put up what they actually do. But yeah, this is a fairly well built unit. We've got a decent earth, which is actually bonded. We've got ferrites on the input power. I actually went through this backwards, so your input side's here. These will be the switch mode controllers over here. We've got an optocoupler there feeding back, as you would have on a switch mode, and then all of this is involved in the modified sine. So your NE555 will be used to generate the waveform, and I'm guessing the 4013 is being used in conjunction with the transistors to drive everything. I think that's it. We've got low battery warning on here, which is quite possibly done by that if that is an op amp. But there's not much to them. But the drawback is you can't use them with some stuff. Certainly capacitive droppers do not like them. I'd need to go and check the list of things that you can't really use them with. However, for running medical equipment on these, that's a big hell no. We make a point of only fitting pure sine to anything that's going to go out and work in a medical capacity in any point in its future. Anything that's going to be running sensitive electronics will be pure sine, and certainly anything that is definitely going out to do medical work will be pure sine. There are many problems with modified sine, which I could probably make an entire video about, but I'll list a few of them down below in the text. But that's all there is, and it's a lot nicer and easier than having a enormous toroid or open frame transformer. But the price you're paying for that is the fact that you can't run everything on this. So anyway, hope that was enlightening, so to speak, and I'll catch you soon. Just as I screw this back together, the kit that springs to mind with these is the Maplin one, which I think was 150 watts. It used a 12012 output transformer for the inverter. I think it stuck around for quite some time in Maplin's catalogue. There was a more efficient, much larger Velleman? I've never worked that one out. One that was introduced to their catalogue when they started selling all the Velleman kits. But I think the original Maplin one hung on for quite some time. If you were around in this period, you'll remember the Maplin had quite a few kits actually that of their own that were really quite good. I really wanted to build 2 of the 1 kilowatt MOSFET kits that they did for the longest time. But yeah, I know you can still buy kits, and it's something that we're looking at putting in our online shop, but they sort of died a death really now. There's a lot more of throwing stuff together with Arduinos and things like that, which I don't want to detract from. It's great, you're learning, and you can do a lot more with an Arduino than you can do with a handful of logic chips, but there's something about the old chunky analog engineering that really isn't covered by that, and perhaps more people should be doing these kits just to get that knowledge. Your Arduino isn't working quite properly because your power supply is junk. Well, do you know how to troubleshoot your power supply? Anyway, that's by the by. I'm off again.